Good day, teachers and learners. I am Sahada B. Canapea, Bachelor of Secondary Education, major in Science 3. Today, I am discussing to you the relationship between electricity and magnetism. So first, what is electricity? Electricity is a form of energy that is transmitted through the wires, especially copper wires, for operating the various machines and devices such as lights, fans, refrigerator, computers, a television, air conditioner, washing machines, and etc. And electricity is the property of charged particles, such as electrons and protons. When these particles are at the rest, it is called static electricity. When we say static electricity, it occurs due to the existence of charged particles. And what is magnetism? Magnetism is a type of attractive or repulsive force that acts up to certain distance. The distance up to which this attractive or repulsive force acts is called magnetic field. Magnetism is caused by the moving electric charges, especially electrons. When two magnetic materials are placed close to each other, they experience an attractive or repulsive force. So as an example of relationship between electricity and magnetism, it is called electromagnet. And an electromagnet causes the fan blades to turn. Electricity and magnetism are closely related. Flowing electrons produce a magnetic field, and spinning magnets cause an electric current to flow. Electromagnetism is in the interaction of these two important forces. So, in the early days, scientists believed that electricity and magnetism are two separate forces. However, after the publication of James Clerk Maxwell, these forces are treated as interrelated forces. So as we can see in the illustration, it is a compass. So magnetism causes a compass needle to point north, unless it is in the presence of a different magnetic field. In 1820, Hans Christian Ørsted observed that a compass needle did not point north when he held it near an electric current flowing through a wire. After further experimentation, he concluded that the electric current in the wire produced a magnetic field. So, here we are in electromagnetic force. So as we can see in the illustration, in the same way that spinning electrons create a magnetic field, traveling electric charges also create a magnetic field. Okay, so let's go further to the relationship of electricity and magnets, or magnetism. So, electromagnetic force, it is the forces of magnetism and electricity are both caused by electric charges. When we say magnetism, it is an electrons spinning, as we can see in the illustration, and electricity, it is an electrons traveling. So, Ørsted experiment showed the relationship of electricity and magnetism. According to the right-hand rule, the electron current in a wire and the magnetic field it generates are perpendicular to each other. So, as we can see in the illustration, electromagnet is a coil of current carrying a wire with an iron core. So, the more turns, the stronger the magnet. When an electric current is passed through a coil of wire wrapped around a core, a very strong magnetic field is produced. So, this is called an electromagnet. That is the relationship between electricity and magnetism.